Hello students. In this lecture, we are going to learn about the OSI model. The OSI model was established by ISO organization that was established in 1947. So ISO organization is a multinational body which is worldwide with agreement with international standards. So ISO also standardized the all aspects of network communication. So whatever the aspects that are related to the network, they came under the open system interconnection model, that is we called as the OSI model. It was introduced in the late 70s. So this OSI model comprises of three major points, that is a layered architecture, peer-to-peer processing, and encapsulation. So ISO is the organization and OSI is the model name. So now, what is exactly OSI is all about? So as we have seen that in networking, by passing a single message from one device to another device, we have to go through the many steps. There are many things that is involved in just a data communication, from encryption, from sending data in the bits, to transferring the data in a machine readable format, to transferring the data in the correct source. If you are sending a mail, it has to be updated in a mail only. So these are all aspects of any networking communication, data communication. So how you divide this task? So OSI model suggested the 7 layers, that these all the tasks for a single data communication, they'll be doing their own work. These are the 7 layers. So OSI model is like a theoretical model. This is a theory model because it is being proposed after the deciding the which task to be divided in which layers. So there are 7 layers they have decided. The first one is a physical, second one is a data link, third one is a network, fourth one is a transport, and fifth one is a session, sixth one is a presentation, and seventh one is the application. So for abbreviation, you can remember it as a आज फिर से टेस्ट नहीं देना पड़ेगा. That is from upside down. So while writing any OSI model, you're supposed to know that when you talk about a message sending from sender to receiver, we have to go from 7 to 1, that is application to physical. Now we are talking about the receiving of message at the receiver, and we are talking about the physical to application level communication. Okay, so each layer has their own set of tasks, and each layer works with other layers to provide a efficient communication. So how this works, let's see. So as you can see, there are two devices. They are connected with intermediate node. Okay, and there are 7 layers. So each 7 layers, they are common for device A and device B. There is some layers which are above and some layers are which are below the transport layer. The layers above to the transport layer are the software layers which implemented in a software form, and the layers below the transport layer, they are the mostly hardware based layers. Okay, so we have seen that 1 2 3, that is the data link layer, physical layer, and network layer. This layer plays a part in a physical communication. Okay, so after the fourth layer, we are dealing with the software part of communication. So here is there is an interface between existed between the two layers, that is a interface we are calling. So why this interface are for? Each layer has to provide some services to the layer above it, and above layer uses that services to provide the services to the another layer. So this happens in a cumulative way. So in this way, each layer is working for another layer that are just above it. So each layer has their own set of tasks they have to perform on the data that is being sent. So how this layer communicate? There is a concept of peer-to-peer communication. So what is peer-to-peer communication? So if you take an example of any office. So for example, if there is a one minister wants to talk to the another minister, so how they will communicate? They will either directly connect with each other. Okay. What is another way? The minister will tell its secretary to connect the meeting with the person. The secretary will pass the message to the peon, and the peon will talk to the peon of another minister. So the communication between peon is happening on the peon to peon level. So peon will forward this message to the secretary. So secretary will talk to the secretary of that minister what is the agenda of the meeting. Okay. So the secretary will share the details of the meeting, and now the secretary will finally talk to the minister that this is the all about the meeting and the minister wants to talk to you. So this is what we call layer to layer communication. So peon people are talking on their level of understanding. The secretary people are talking on their level of understanding, and the minister people, they are the actual sender and receiver of the meeting. In same way, each layer communicates with another layer of the another device. So application layer has a communication with the application layer of the another device that you are sending a message. So how this works? Since every layer has their own understanding of data unit, so each layer has the data unit different for each layer. So for example, if you are talking about the data in terms of bits, so it is transferred as a transmission medium. So for example, in the physical layer, we having a data as in the form of bits. So physical layer is nothing but a streaming of bits. Whatever data you are sending, that is sent in the form of bits. So this data which is sent which is to be sent in a form of bits, that has to be sent some signal. That signal will be, say, analog or digital. So whatever the signal will be generated after that binary communication, that is transferred to the any medium, say wireless or wired, it is finally forwarded to the receiver. So here we can see that there is some layers having their headers added to the original data, and some layers having their trailers. So trailer and header is only existed in between data link layer. Otherwise, all the layers having only header part. So what is the header part has? Here the D7 is actually data that is being sent by the computer A. Just say it is an email. So that email content or the text body of the email, that is a part of D7. So what is S7? The S7 acting as an address or any information that is related to that application layer, so that it will understand the what is the message is all about. So A7 will carry the addresses of the email. Okay, so which is the domain of email, which is the receiver of email, and this information is passed on to the lower layer, that is the presentation layer. So presentation layer is not aware about what is a H7 or what is a D7. It is encapsulated as a D6. It is just a data for that presentation layer. So presentation layer will add its own header, and this will continues until you reach to the data link layer. In the case of data link layer, you also have a header, you also have a trailer. So the header part of data link layer, it deals with the information of actual physical address of the devices. So we will see that what is the physical address and what is the logical address. So the header part deals with the addressing, physical addressing part, and the T2 is a trailer that has some bits that will help us for error correction and detection, that we are going to see in a unit number 2. So these layers add their own headers to each data unit, and these data units are encapsulated and they finally transmitted to the medium, and these added headers will be removed at each layer. So for example, if H2 is added on the data link layer, the H2 will be removed, H2 and T2 will be removed on the data link layer only. If H3, H4 is added on the transport layer, the H4 will be removed on the transport layer of the receiver only. That is what we call as a peer-to-peer communication. So what is the information intended for the transport layer, that is only read by the transport layer. No other layer will aware about what is transport layer is doing. Okay, so there is a concept of encapsulation also and peer-to-peer communication. So the layer architecture says that the lower layers providing the services to the above layers. So each layer defines the family of functions. So for example, physical layer is dealing with the physical aspects of the data communication, that is the data rate, you can say, the synchronization of the clock, and the topologies of the physical hardware devices. So all these aspects will deal with the physical layer. Data link layer will dealing with the error correction and detection, the flow control part. So each layer will have their own set of services. Okay, so even though each layer has their own set of services, they have to provide some services to the above layer. So for example, data link layer just below the network layer. So data link layer will provide such a services that will in a way help to the network layer to forward it further. Next concept is the peer-to-peer processing. So peer-to-peer process means what? Each layer is in the sending devices adds its own information to the message it receives. So what is that extra information? That is the header we are talking about. Okay. So that becomes a whole package. So each layer at the receiving side, message will be unwrapped. So it is encapsulated on the center side. So it is really unwrapped on the receiver side. So layer 2 only remove the layer data that is meant for only layer 2 only. Okay. So interfaces, that white color interfaces we have seen between two devices, they are acting as a bridging gap. That is, they are like a interfacing. They are providing a layers services of the below layers to the above layers, and that is the concept come from the encapsulation. Okay. So organization layer of a layer is such a way that the lower layers are the telling about the physical aspects of the data. So for example, electrical specification, what are the devices that are being connected, what are the physical addresses are there. Okay. And the layer above the transport, they are dealing with the mostly the supportive or the interoperability part of the software system. So somehow layer 4 is acting as a bridging gap between all these two layers. So sometimes layer 4, the Raspberry is called as the heart of the OSI model. So mostly OSI upper layers are implemented in the software, and the lower layers are the combination of hardware plus software. Physical layer is mostly purely the hardware one because it actually deals with the physical aspect of data. Okay, so this is how the OSI model works. So how it is works? So if you see that there is a header part, the header part always has some data, that information that has to be encapsulated into another data unit. So that data portion packet is encapsulated on the sender side and it is decapsulated into the receiver side. So whatever data is given for T7, that is encapsulated in a D6 as a data, also the header of the layer 7. So H7 and D7 will be collectively encapsulated into the, as we can go backward, you can see this diagram that H7 and D7 acting as a data unit for the layer 6, that is our presentation layer. So as much of now we have seen that there are 7 layers and each layer has their own services. In the next lecture we will see what are these services they are performing and what is the importance of each layer. Thank you.